Hi, hello everyone. Welcome back to my YouTube channel. As you all know, I am Kavishri studying at Sri Venkateshwara College of Engineering. Today I am going to explain about comparison between the stacks and queues, which comes under the subject data structure. Let us explore the fundamental data structure, stacks and queues. Stacks follow the LIFO structure and queues follow the FIFO structure. Let us see the contents of comparison between stacks and queues. First, we are going to define the stacks and key operations of stacks, and later we are going to define queues and operations of queues and similarities between the stacks and queues, difference between stacks and queues, real world applications of stacks and queues. At last, we are going to conclude about the stacks and queues. Let us see the definition of stacks. Stacks in data structure. Stack is a linear data structure that follows the last in first out principle. This means the last element added to the stack is the first one to be removed. It works on the LIFO principle. Let us imagine a stack of plates. You can only add the plates and remove the plates from the top of the stack. The last plate you have added is the first one you take off. Key operations in stacks. There are four operations which are push, pop, pick and isEmpty. The push operation adds an element into the top of the stack which increases the size of the stack. Pop. Pop Pop operation removes the element from the stack and this action decreases the size of the stack. The pick operation returns the element at the top of the stack without removing it, which provides the access to the top element without modifying the stack. isEmpty is the operation which checks if the stack is empty. It returns true if the stack contains no elements, otherwise false. Let us see the definition of queues. First in, first out, which follows the first in, first out principle. It is a linear data structure. The first element which is added to the queues is the first one to be removed. Let us imagine an analogy of the queue. Let us imagine a line of people waiting at the supermarket checkout. The person at the front of the line is the first to be served, and just like the first element added to the queue is the first one to be removed. Let us see the key operations in queues. First is a enqueue. The enqueue operations add an element to the rear end of the queue. It increases the size of the queue. Enqueue is also known as insertion an element to the queue. And dequeue is known as deletion. The dequeue operation removes and returns the element at the front of the queue, which decreases the queue size. Peak. The peak operations return the element at the front of the queue without removing it. isEmpty. It is operation checks if the queue is empty. If it returns true if the queue contains no elements and either it's false. Let us see the similarities between stacks and queues. Linear data structure. Both stacks and queues are the linear data structure. They store the elements in a sequential manner and allow access to the elements based on their position. Abstract data types. Stacks and queues are the abstract data types, ADTs. They define a set of operations that can be performed on data regardless of underlying implementation details. Let us see difference between the stacks and queues. Let us see the definition. The stacks, a linear data structure that follows the last in first out principle, and the queue is a linear data structure which follows first in first out principle. The primary operation of a stack is a push, pop, pick. Push is an operation which can add an item. Pop is an operation to remove an item. Pick is an operation to view the top item. The primary operations of queue or enqueue which adds an item. DQ removes an item, front with the first element, rear which views the last element. Insertion and removal of the stack. Elements are added and removed from the same end. Insertion and removal of the queues. Elements are added at the rear end and removed from the front end. We uses different cases in the stacks. Function call management, which is called as call stack, expression evaluation, syntax parsing, and undo mechanism in the text editors. The use cases of the queues are scheduling processing in operating systems, managing requests in a printer queue, breadth first search in the graphs. Let us see the examples of stacks. Browser history, reversing a word is an example of a stack, and queue example is customer service lines, CPU task scheduling. There are real world analogy or examples of these stacks is a stack of plates. You can add and remove the plates from the top. And for example of the queue, a queue is a ticket counter. The first person in the line is the first one to be served. Let us see the real world application of stacks. Function called stacks. When the function is called, its local variables and parameters are pushed onto the stack. Undo and redo functionalities. Many applications use stacks to implement undo and redo features, storing user actions to revert to the previous states. Expression evaluations. Stacks are used in compilers to evaluate arithmetic operations following the order of the operation. Real world applications of queues. Print queues. Print jobs are added to the queue and processed in the order they are received. Task scheduling. Operating systems are the queues to manage tasks, prioritize and execute them efficiently. Network requesters. Web services use queues to handle incoming requests, ensuring fair processing and preventing the overloading. Let us see the conclusion. Right data structure. First, we have to use the data access pattern LIFO, stacks or FIFO queues. Second is the application requirements function call, undo or redo or task scheduling. Third is data structure choice. Is it a stack or a queue? Choosing the right data structure is crucial for efficient and effective programming. By understanding the characteristics of stacks and queues and considering the specific requirements of the application, developers can select the data structure that suits best and handle the task very easily. Thank you for watching.